Unit 6, Lesson 2, Compound Inequalities. I'm going to start with the Lesson 2 warm-up. So it says pick the best answer to translate the verbal expressions. So we're looking for a way to notate these inequalities in these word sentences. So first we need to figure out what kind of inequality we're dealing with, what symbol we're dealing with, and what's our keyword. So to enter a junior writing competition, you must be under 12 years old. Which of the following is correct? So under means you're going to be below or less than 12. Below or less than 12. So your age has to be under. It doesn't have to be equal to. It just has to be under. So it's A. The next, it says to drive a car, your age must be 16 or over. So it must be equal to 16 or greater than 16. So equal to or greater than. Okay, so that would be D. To be a heavyweight boxer, you should weigh more than. You should be way more than. So your weight should be greater than 200. Weight should be greater than 200. Doesn't have to be equal to. So it's C. For graphing this inequality, you're going to have to solve for it first. So I would, let's set this up correctly here. So you're going to subtract 2 on both sides, minus 2 of that equal sign. And what I end up with is x. X is less than 5. Okay? So x is less than 5, find 5, and if it's less than, all the values less than 5 are towards the left of 5. For the next one, you add 4 to both sides. Add 4, right? So that's going to leave me with, add 4 to both sides. That's going to leave me with x. So x is greater than or equal to -2. So I go find my -2. It's a filled in circle. If it's greater, numbers that are greater than -2 are towards the left. They are towards the left. So I would start here and go all the way to. I'm sorry. Correction, towards the right. Towards the right. All right. So you write an inequality that represents the statement x is greater than 2. So I always start with my symbol. It's greater, and x is greater than 2. A number is less than or equal to a number, so x is less than. It's also equal to and 5. All right. Last one, write the inequality that the graph represents. So these are all my x values. These x values are greater than some number. They're greater than. The circle is filled in, so it's equal to -2. So I hope that was relatively easy for you all. Okay, so we're gonna get started. So what we're working on today is something called compound inequalities. So there's 2 types of compound inequalities. There's the and statement, and then there's the or statement. So the and compound inequality is a solid statement that goes from left to right, and the graph is a line between 2 numbers. So the way I know I'm looking at an and statement looks something like this. Looks something like this. You have 2 numbers. Let's say we have 2 and we'll say 5. Then all the numbers in between, these are your x's. And we can create an inequality. Since it's filled in, 2 is less than or equal to, x is less than or equal to 5. On the other hand, the or statement is like 2 pairs of opposite rays going in opposite directions. So this would be an or statement. And it consists of broken statements, and the graphs and statements go in opposite directions, starting at 2 numbers. So we're going to look at those and what they look like. So what I'm going to ask you to do is to not focus so much on putting numbers on this number line, but putting the two numbers that you see. So -2 and 4. So -2 and 4. Don't worry about it being even. Just worry about putting the numbers on the number lines. -2 and 4. So if this is an and statement, all of the numbers between -2 and 4, and it's equal to, so I'm going to have filled in circles here, filled in circles, all of the numbers between -2 and 4 fall into, it's right here. That's all of the numbers between -2 and 4. If I were going to create the interval, I use hard brackets for filled in circles. So hard bracket here, and I just collect my two endpoints. So the first endpoint, -2, comma 4, close the interval. And a little bit of just heads up, we are going to be using those infinity symbols today. This graph does not go towards negative infinity, but just a little heads up that we will be going over that. So on this side, it's positive infinity. Now let's look at the second one, this OR statement. Now the OR statement, it goes in opposite directions. So we always want the smallest number first. So the smallest number here is -1, and this time we'll number this 0, 1, 2, 3, and 4. All right, and we'll put -2 on the end over here. Now, for this first inequality, it's equal to at -1, so I'm gonna fill in the circle there. And then for the second one, it is not equal to, it's just a whole. So the OR statement's always easy. You are creating opposite rays. Opposite rays. So for my first opposite ray, I'm going towards the right. And for the second opposite ray, I'm going towards the left. And I want to fill that in, so I'm going to pick a different color here. But that's what it looks like. It's two rays going in opposite directions. Okay. And the endpoints are numbers. So if I was going to write this is where negative infinity and positive infinity come in handy here. So we're going to look at these two intervals separately. So your starting point on the left would be negative infinity. I'll go all the way over to 1, and it's filled in, so it's going to be a hard bracket. And then we create something called a union for our OR statements. This is a Unit 2 concept. Sorry, guys. Unit 3 concept. Then for the second interval, this one right here between 2, and it's going all the way to the right to positive infinity. This one is 2, comma, infinity. Okay? So keeping that in mind, and statements create these simple little interval notations, whereas the OR statements, you have two individual interval notations. Okay? So that means for the next one, I should have some negative infinity going on here, and some positive infinity going on in my interval notation in my next OR statement. Okay, but we're going to do the AND statement first. So for the AND statement, I'm just going to put my numbers on there, -1 and 3, right? It's filled in at -1. It's a big gaping hole at 3. And I know for a fact that I'm just joining these two lines, these 2 points together. Now the interval notation, since it's a hard bracket, it's going to be since it's filled in, it's going to be a hard bracket here, and since it's open, it's going to be a parentheses here. So hard brackets, -1, comma, 3, and then a parentheses. Okay. Over here, there's no equal to. We just have 2, and we have 4. It's not filled in, so there's no equal to. So, and I'm gonna do my opposite rays here. Just make them blue. Okay. There's 1, and there's 1. So on the left, I'm coming from negative infinity over to 2, and it's all parentheses here, right? Do my union, start back up at 4, it's all parentheses because there is no filled in circles, comma, positive infinity. So good job so far, guys. All right, so below, we're just gonna notate what this looks like. I know for 1, 2, and the last one, it's just going to be one continuous segment. There's no broken parts. So from -1, -1, all the way up to 10. Don't worry about perfection here. All right, but from -1 to 10, and it's an open circle at -1 because of the parentheses. It's a closed circle at 10 because of the hard bracket, and I just joined the lines together. If I were going to do set notation, I would have -1 less than x less than or equal to 10. So a couple of different things going on. We're going to do set notation and graph the actual interval notation. All right, so for the next one, we have between -3, and if you notice, I'm just picking random tick marks. And I have 2 hard or square brackets, so it's filled in at both of these, which means it's equal to, and all of those x values are in between, and we show that by joining the 2 endpoints. So here, set notation will be -3 is less than or equal to x is less than or equal to 3. All right, this OR statement, on the other hand, I have 0, and then I have 5 somewhere over here on the right, and it looks like it's filled in, so it's equal to. All of these x values are less than 0. There's 1, okay, and then at 5, it's open circle because of the parentheses, and it's going towards positive infinity. And all of these x values are greater than 5. So I have 2 set notations. I have x is less than or equal to 0, or 5 is less than x. Now from the next one, it's 3 to infinity. So we're going to just find 3 here. Doesn't matter about what's on the left or right. I just know that the numbers are bigger on the right, and they're going towards positive infinity. So my graph looks like this. So all my x values are right over here. So 3 is less than, and it's equal to, because of the square bracket, x. All of these x values. Okay? Hope that was relatively easy for you. The next section covers solving these and or statements. So that's going to be video number